Hello everyone, in this video I will be explaining a problem reverse of permutation. So it was asked in Codeforces around 1076 for division 3. So let's read out the problem. A permutation of length n is an array consisting of n distinct integers from 1 to n in arbitrary order. For example, 2, 3, 1, 5, 4 is a permutation of when n is 5, we can say, because we have all the integers from 1 to n, 1, 2, 3, 4, 5. But 1, 2, 2 and 1, 3, 4 are not permutation because the array length is 3, so we should be expecting 3 in this, but we have 1, 2, 2, like 2 times 2 is repeated, so it's not a valid one. And 1, 3, 4 is also not a permutation because length is 3, we should not be expecting 4 in this case. Yeah. So you are given a permutation p of length n. You can perform the following operation exactly once. Yeah, we can do this operation exactly once. Choose integers l comma r, okay, and it should be in the range from left to 1 to n. Reverse the segment l to right, yeah, from the whatever left right you have chosen the indices, so you have to reverse the segment in the permutation p, and your task is to output the lexicographically maximum permutation that can be obtained by performing this operation. A permutation A is lexicographically greater than permutation B if for the first position I where they differ it holds that A of I greater than B of I. Okay, so this problem looks good, so I'll tell you it's a nice problem. Input we have test cases, and we for every test case we have integer n denoting the length of the permutation, and in the second line we have a permutation order. Okay, so we have to print the maximum permutation. Okay, so let's consider for example we have ns4 and 3214. We have 3214. So n they've given is 4 in the first test case, and your permutation is 3214. So let me tell you what the problem statement is. They have given one permutation p. Okay, it is a permutation of length n. Okay, so any permutation of length n will have elements p of I in the range 1 to n, and this p of I elements will be unique, right? So these two statements are very important in permutation. Example, we can say when n is 3, you can take 1, 2, 3 as one of the permutation, or you can take 3, 1, 2 as a permutation. But if you want to choose one, if you want to take 1, 2, 2, this is not a permutation because the condition says p of I should be in the range 1 to n. Okay, so all the elements are in the range 1 to n, that is fine. But the second statement says p of I has to be unique. All okay, so if you see here 2, it has occurred 2 times, so it is not permutation. If you consider 1, 3, 4, so it violates first condition. The first condition is it should be in the range 1 to n, so its length is 3, right? Here n is 3, but your here you have 4 element, element as 4, which is out of the bound. So this is the definition of permutation. Now they have asked you, they've given one of the permutation p. Okay, they've given one of the permutation p. Now we need to make sure lexicographically spellings are, yeah, we have to print the lexicographically greatest element, greatest permutation. Okay, in doing this what you can choose is you can choose L and R indices. Okay, your L should be L should be greater than equals to 1 but less than equals to R. R should be greater than equals to L. L should be less than equals to N. So whatever indices you have chosen in permutation, like you have permutation this way, let's say L to R, this range of chosen, you can reverse that segment basically. Okay. So you need to perform this operation by doing, you can do that. So first thing first, what I'll do is, if you want the lexicographically the greatest permutation, so since the permutations, permutation array is in the range from 1 to n, I want here to be the greatest element, which is 4, because its length is 4. Then I want to be 3, then I want to be 2, then I want to be 1. If this is the permutation, then this is the max possible, lexicographically greatest. So if you compare these two, now here it should have been 4 but you have 3. So which means here is the particular index where it is missing. What if you had something like this? Let's say 4, 1, 2, 3, you had something like this. If you had this way, see 4 and 4 are matching. So this position is secured. But next what we want 3. So here it is not secured. So your left would be, left index would be here at this position. But right now in your given array it is left here. And since you want L to be, you want here to be 4, so you need to find where my 4 is. You have to go iterate in the array. You have found 4 here, it is R. Okay, now if you reverse this, what will happen? 4, 1, 2, 3, this is what you are going to get, and you need to do this operation only once, not more than once. If you were allowed to do multiple times, then easily you would return only this permutation, because if there are multiple operations to be allowed, so easily you can get to this decreasing order. So only one operation is allowed. That's why we will compare with the highest lexicographical order, and if at any position something is missing, mismatch, so that would be your left. And what is the mismatch? That index your that element you will find, and that will be your right index. You just need to reverse it. In this case also, let's consider this as second example. What you will do is, you have 4, okay, and you need next as 3, but 3 is not there. So what you will do is, this is your left index. Now you will try to find 3. 3 is here. This is right index. Now you will try to reverse it, L to R. So it is going to be 3, 1, 3, 2, 1. Okay, because you are reversing. So this is the highest lexicographically permutation. So I think you have understood what we are trying to do. Basically, we need to check lexicographic greatest permutation you want, right? So we need to check which, from the starting we need to check the decreasing order. If at any position you're finding that decreasing order is not there, so in that case you'll have to make sure that is your left index. And what should have been the actual element here, that you need to find in the next, on the right hand side of the permutation, that will be your R. So you need to reverse LNR, right? So in the code, what I'll be doing is, I'll be taking one num variable which I'll initialize to n, which is maximum possible. Now I'll check if your num, this num is equals to, I'll iterate from left to right, right? I'll iterate from left to right. So I'll check if your p of I is not equals to num, which means you have got a left index. Update L with R, L with I. Once you have got this, break out of the loop. I'll break. So now it's like you want num at this p of I, but it is not there. So this num you want in the right hand side. Now again one more for loop will take 0 to n minus 1, and you will check if p of I is equals to num. So in that case your R is going to be I, and you need to break. And after these two for loops you need to just reverse the LNR, and you have to print it. So I think you have understood the problem statement. Let's try to code it up. So let's take the inputs. We have test cases. Test cases have taken care of this position. For every test case, I'm calling a solve function, and we have integer n as the length of the permutation, and next line we have distinct, I mean one of the permutations they've given. So we are taking the permutation. Okay, now we'll take L and initialize to -1. Why I'm initializing to -1, I'll tell you. Because let's say one of the condition case wherein you have 4 3 2 1, this is the highest lexicographically permutation, right? So in this case, in the for loop whatever I'm writing, you will not find L, any index which is mismatching. Your num is initialized to n. Now I need to check if p of I is not equals to num, which means here we have a mismatch. If it is a mismatch, then your L is updated to I and you need to break. Okay, and every time you need to decrease nums, because highest element you have taken, next highest element you need to take. Now here you need to check if L is -1, which means in the above the P of I elements were equals to the num, I mean num order. Okay, so that's why in this, if you have not went and then L is -1 only, so it's like you have the highest permutation only. So if that is the case, then you need to print the permutation. Whatever permutation you have, that is the answer. You don't need to reverse anything. Okay, so what I'll do is, if I'll make the reverse case, like if L is not equals to -1, which means there is a mismatch. Now we need to find the R as well, right? I'll take R, which is initialized to nothing initially. Now what I'll do is I'll run a loop. I'll try to find the R. How do you find R? Because since in nums you have the mismatch value, so we need to find if P of I is equals to num. So in that case, you have got actually R. R is I. You need to break it out. So once you break it out, you need to reverse plus L comma R plus 1. Why I'm taking R plus 1? Because if you are reversing from this index to this index, so you need to take the next index, because last one is not inclusive, that's why. Okay, now we need to print it. Let's try to run. Yeah, it is getting passed. Let's try to submit it. Reverse a permutation. Yeah, it got accepted, and in this way you could have easily solved the problem. So it's a good problem, like it's a greedy one only, not a big deal. So yeah, thank you guys for watching the video.